Welcome to the third installment of the MoleculeCrafter video tutorial. Here we'll talk about actually extracting the data from the MMSIF file. To get the data we need, we have created the MoleculeCrafter guided parser. This tool is a Google Colab notebook which allows the user to run our custom Python script without requiring that the user have Python downloaded to their device. This is the guided parser page. It has a lot of step-by-step instructions for new users. I'll go over a few of them now. So, what does this code do? It installs the library BioPython, which is used for computational biology and will allow us to parse the raw data in the MMSIF file. This code also uploads that MMSIF file that we've been working on so far, and it also takes the 4-digit PDB code as an input. Then it will allow you to run one of two types of parsers. The first is the standard guided parser, and this is more instructional and helps new users. You can also run the fast residue parser, which does the same thing as the standard guide parser, except it's streamlined to export more than one residue at a time and is meant for more advanced users. There are a few important notes about working in Google Colab. To execute a code block, select the code block and then press Shift-Enter or press the play button. Note that every time you reopen this file, you will need to run each code block again. This means you will need to reinstall BioPython, re-upload your chosen molecule, and retype the molecule's PDB code. Note that sometimes the output will remain displayed from a previous session. This does not mean that output is valid. You will still need to run the code blocks again. This also means the CSV files you output will not be saved either. If you forget to run a prior code block, then the following code blocks will throw an error. This means you'll need to go back and check anything you've done before. Additionally, some outputs will be very long, especially those outputs for the standard guided parser. To clear or hide outputs, click the output icon and then select Show or Hide. Now, let's get started actually using the guided parser. First thing we need to do is install BioPython. So I'll go and press the play arrow. This will take a second, but if I need to... Oh, there, it's already downloaded. Okay, the next thing to do is to upload our file. So I need to go to this code block and press play again. It'll pop up with a Choose File option. I'll select Choose File, and then I want to click my 1BNA-H CIF. This is the file that I just added the hydrogens to. I press Open, and now my file is uploaded. Now I need to type in my PDB code. So this already has 1BNA typed in it because I've done this before, but this does not mean it has actually been run because I need to type it in and then I need to press Run. And once this little check mark shows up, I know that this code cell has actually been executed. This is an easy step for people to skip, so you want to make sure that you always see this little green check before you move on to the next section. Now, I have my choice between the two parsers, the standard guided parser and the fast parser. Each of these have a little instruction about why each parser is different. Basically, this parser will walk you through whether you want to model an entity, model, chain, or residue substructure of your molecule. Typically, you will only ever want to model a residue, but this parser gives you the option of exporting something larger. This is also meant to be a learning tool. You can show the code here, however, it is extremely long, so mostly we keep it hidden, and you don't actually need to see the code in order to run the cell. So, if I start with this standard parser, I can press play, and it pops up with this information. So it tells me my structure is this DNA structure, and it also includes water. And they have the following entity IDs, 1 and 2, and they are a polymer and a water. So it's asking me if I want to see a greater breakdown of the structure or if I want to model one of these entities now. I can type yes to see a further breakdown, or I can type the ID number of the entity I want to model. Well, I don't want to model either of these entities. I want to break it down more. So I'm going to type yes. It must be in all caps. Okay, it's telling me this structure contains the following models. It only has one model, and its ID is 0. Do I want to break it down, or do I want to model this one? I want to break it down. Okay, so this structure contains two chains, chain A and chain B. Do I want to model a chain, or do I want to break this down more? I want to break this down more, so I'm going to type a yes. Okay, now we're down at residues. You can see we have 4 residues plus water. So, which of these residues do I want to model? Well, as we've mentioned before, I would like to model a cytosine. If I go here, I can see, oh yes, my first one was a cytosine, chain B, sequence 15. Okay, so I type in DC, no spaces. Okay. It's telling me that polymer residues occur in a chain sequence. Would I like to model any occurrence of cytosine, or do I know the sequence number that I've selected? So if I don't know a sequence number, then I can just type yes, and this will give me any cytosine. If I do know the sequence number, I can type in a specific one. Now, it's usually best to know the sequence number. And in this case, I already figured out what all my sequence numbers are. So I'm going to do that. I want sequence 15. So if I want to type in the sequence number, okay, type no if I do have a specific sequence number and don't want it to just give me a default number. So I'm going to type in no. So what's my sequence number? It was 15, yes. Okay, so I'll type in 15. Now, there's multiple chains in this structure, so which chain do I want to take that residue from? I wrote down that it was on chain B, so I'm going to type in B. This residue also allows you to export neighbors. Basically, it's a tool that finds all of the various residues that are nearby to the one that you've chosen. And here's this list of residues that it has output right here. Some of these may even be the ones that I've already picked out for myself. However, it'll probably also give you a lot of extra ones. If you're new and want to just export all the neighbors to try it out, you can type yes to export neighbors. But because I've planned everything out carefully, I'm going to type no. Okay, so my chosen body has been successfully exported as a CSV file, and it's been given this name. This is the following list of neighbors that it found, but they have not been exported, and this is only for reference. If I had exported them, they all would have been exported as well. Now, the rest of this talks about how we can access the file. Basically, you go to the file icon, and you can find 1BNA Model 0 Chain B. If I click on this file, I can see some of it up here. You can see there's multiple pages. I'm just going to show 100. And I can see that this is in the proper format. I can go here, close tab again. So now I've managed to get my first residue downloaded. I still need to get those other residues downloaded. If I went through this, I can easily go through this process in the standard guided parser again. However, sometimes that can take a while. I can also run the fast residue parser. This is often the better parser to use when trying to export a well-planned selection of residues, which means that's what I'm going to do now. So I'm going to run the fast residue parser. It mentions there are 104 residues in this structure, and they have these distinct component residues. Which one would I like to model? Well, what's the next one on our list? DG. Okay, so I'm going to type in DG. What sequence number would I like? That was DG sequence 10. So I type in 10. Multiple chains. What chain? DG sequence 10, chain A. Okay. I've parsed this file. Would I like to select an additional residue? Yes or no? I want to add another residue. So which one do I want? That's DA. What sequence number? That's DA sequence 17. Sequence 17 on chain B. Now I've got that sequence down. Okay, do I want to do another? I do. Okay, now I've just done 17, so now I'm on DT, thymine. And I need DT, which is sequence 8. And I remember that was chain A. Okay, I've got another one. Now I'm going to add another Yes. Just did DT sequence 8, so I'm going to do DT sequence 7. DT sequence 7. And this sequence 7 was on chain A. That's another one exported, and I have one left. Okay, and that was DA of sequence 6 on chain A. Okay, and now I've got all the ones that I need. So I don't want to type yes, I want to type no, because I'm done with my list and I want to export them. Okay, my chosen bodies have been successfully exported as CSV files. Check my computer. They're in the same space as the other one, and now we can see this full list of my CSVs. So as you can see, the fast residue parser goes a lot faster than the standard guided parser. However, the standard parser is very helpful for anyone who's new to learning about how the structures break down. Now that I have these, I can download the files to my computer. And that's all for step 3 of our tutorial. We have learned how to use our custom guided parser to extract the necessary molecular data from our MMSIF files. Up next, we will discuss using the MoleculeCrafter workspace in Onshape to create molecules and add connectors.